Hey there, Python trainer Reuven Lerner here, and today I want to show you how to replace values in a Pandas data frame. So first I have to set things up a little bit. I'm going to say import numpy as np, import pandas as pd, and from pandas import data frame because I'm going to use that. And then I'm going to use some random numbers here. So I'm going to say np random seed 0, and that's going to guarantee we always get the same results. And now we can finally create our data frame. I'm going to say df equals a data frame based on np random randint. So we're going to have random integers here from 0 to 10. And what I want to have is 4 by 5. So we're going to have 4 rows and 5 columns. And we're going to say then index equals a list of A, B. Well, let's do W, X, Y, Z. And we'll say here the columns are a list of A, B, C, D, E. And we look here, and sure enough, we have 4 rows, W, X, Y, Z. We have 5 columns, A, B, C, D, E. And we have a whole bunch of one-digit numbers from 0 through 9. So far, so good. And what I want to do is show you now how we can replace values here. So first of all, I can do replacing on a per column basis. So I can say here, df of c, replace, right? And does replace exist here? Well, it's a method, so I can say here, replace 3 with 99. And look at that. So df of c replace, so we can replace one value there. But what if I do that on the entire data frame? What if I say here, df replace 3 with 99? Well, we see then that all of the places in which we have 3 are now replaced with 99. So you can already see that the series version of replace works on, of course, a single series, a single column, whereas the data frame version of replace works across the entire data frame. It doesn't matter where the value is. We're going to replace 3 with 99. Yeah, but what if we want to replace a few different things? What if I want to replace 6 to be 96 and 7 to be 97, right? And 8 to be 98. Well, then I can say df replace. And there are actually 2 different ways I can do this. I can say here 6, 7, 8. Look at that. It's a list. Are going to be then 96, 97, 98. And now wherever there was previously a 6, 1, 2 of them right here, so we're going to get 96. Wherever there was a 7, we're going to get 97. And wherever there was an 8, we're going to get a 98. By the way, I should add, notice that in all these cases of using replace, we're getting back a new data structure. So you run replace on a series, we get back a new series. You run replace on a data frame, you get back a new data frame. In theory, you could modify the existing series or data frame using in place equals true as a keyword argument. Don't do it. The Pandas core developers have made it clear that in place equals true is a bad idea. It's something you don't want to do, and it will be removed from Pandas at some point in the future. How soon, I'm not sure, but it will be removed. Don't do it. And if you think, oh, but it saves a lot of memory, apparently not true. So you can see that then by providing a list here, and the lists have to be exactly the same length, I can say 6 becomes 96, 7 becomes 97, 8 becomes 98. And you might be saying, wait a second. Surely, we could somehow have a better way to say that 6 becomes 96, 7 becomes 97, 8 becomes 98. Maybe we could use a dictionary instead, and indeed we can. I can say df replace, and I can say here in a dictionary 6 becomes 96, 7 becomes 97, and 8 becomes 98. And then we're going to get back exactly the same result as before, but I happen to like this dictionary way of doing it. I think it's a little clearer, certainly a bit shorter, but we get the same result. And dictionaries are just great in general, right? Well, what if we want to do something a little different? What if I want to, turn 6 into 96 in column B and turn 7 into 97 in column C and turn 8 into 98 in column D? Right, but we want to ignore 6 outside of column B. We want to ignore 7 outside of column C, and we want to ignore 8 outside of column D. Well, this is where our dictionary syntax becomes really cool. I can say df replace of, I'm going to say 6 colon. Actually, I'm not going to. I'm going to say here B colon. That's going to be my key. And my value is going to be a new dictionary. And the dictionary is going to be 696. And then I can say C is going to be a dictionary of 797. And I can say D is going to be a dictionary of 898. And so this is a way of representing exactly what I just said. And I want to add also Sometimes people learn pandas and they don't really truly understand Python. This is a case in which understanding dictionaries and how they work and that you can nest them really comes in handy. You don't need super, super deep understanding of basic Python data structures, but the more you understand them, the better it'll be. And sure enough, now if I run this, we see that 6 in column A remained there, but 6 in column B was changed. 7 in column B remained there, but 7 in column C was changed. And 8 in column C remained there, but 8 in column D was changed, which is pretty snazzy, I'd say. So if you have values that you want to replace in pandas, the replace method is a fantastic way to do it. And just to make it clear, if I want to actually keep these values, right, keep the values that I've set in replace, so assign the result back to the original variable. And so if I do that here, df equals all this stuff, now of course my data frame refers to the new one that we got back from calling df replace, and now all is well. I hope this was helpful and useful. If you have more questions, leave them in the comments. Don't forget, you can catch me here all the time with new videos about Python and pandas. I'm also on Twitter, frequently tweeting about, what do you know, Python and pandas. And don't forget my free weekly newsletter, Better Developers. I've got, 27,000 subscribers now, and it's fantastic if you want to join, and I'd love to hear from you. I'll be back soon with more on the Python front. See you then.